Hi, we are Wind Speed, Shreya Nimmagadda, Connor Smith, and Cian Hamilton. Some of the current goals of wind turbines are to improve wind plant power production, reduce operation costs, expand wind turbine markets, begin mass production, and increase performance and design. A future goal of the United States is to have 20% wind energy by 2030.
Engineers solve problems, and just as scientists have the scientific method, engineers have the design cycle, which is a set of steps that help address problems and create solutions. The design cycle includes defining a problem, doing background research, knowing your specific requirements, brainstorming ideas, prototyping, and testing over and over again. As a nation, we depend heavily on non-renewable natural resources, such as gas and coal. And wind power has potential because it's renewable and continues to improve producing energy at a more effective rate. Wind is a type of solar energy, which is a result of the combination of the uneven heating of the Earth's surface by the atmosphere, the Earth spinning, and the Earth's irregular surface. In wind turbines, kinetic energy from the wind is converted into mechanical power, which goes to a generator that produces electricity. For our specific problem, we demonstrated how kinetic energy is converted into electrical energy within a 3x3 foot space, all on a $40 budget. We displayed the production of electricity through the use of a red light which required 3.3 volts and our voltmeter which read 2 volts, producing a total of 5.3 volts at max speed. After considering many types of designs, we assembled a cage wind turbine made out of PVC pipes, a fan, a generator, and turbine blades. Once we created our final product, we continued to test the turbine, making sure there would be no hiccups on design day. One of our greatest problems throughout the project was finding blades that would spin the most effectively when the source of wind was coming from the bottom. This process required a lot of trial and error, but eventually found a blade that worked the best.
Honestly, the most difficult part of this process was finding a set of blades that would work with a perpendicular wind current. After looking through many different blades, I remembered a toy set I had at home that had a propeller blade that I thought would work perfectly for this project, and luckily it did. As far as the PVC goes, we decided to go with a cage design to put around our turbine. We did this to draw attention to the project so that people would come over, ask what it was, and we could give our spiel about wind turbines. Connor also found this a much easier way to carry our project. If I were to do anything differently, I think it would be trying to make a more efficient generator so that we could read a higher voltage on our voltmeter. That would have also boosted our scores with the judges for that particular piece of the project. As far as advice goes, I have 3 main points. Know your project very well so that there's no chance of disqualification when you're presenting at Fed. The second one is to prepare your speech as much as possible so that if you are asked to present in front of judges, you will be very prepared. And the third is great advice for anything: do not wait until last second to begin your project. You have a couple months. It flies by a lot faster than most people think.
The energy in the wind, called kinetic energy, turns the turbine blades around the rotor, creating mechanical energy. The rotor connects to the main shaft, which turns inside the generator housing. Here, a magnetic rotor spins inside loops of copper wire. This causes electrons inside the copper to flow, creating electrical energy, what we call electricity in our daily lives. For this wind turbine, a step-up transformer inside the nacelle increases the electrical generation from 690 volts to 3,400 volts. The electricity generated then travels down large cables from the nacelle through the tower and into underground cables. The cables take the electricity generated from all the wind turbines to a substation. Here, a step-up transformer again increases the electrical output. A transmission line connects the electricity output at the substation to the electrical grid serving communities throughout the region.